Hi and welcome. Today we'll be talking about the quadratic formula and the discriminant, and they're both not interchangeable, but they both are attached at the hip. Okay, now first off, let's start with the quadratic formula. Now the quadratic formula is this big old honking looking thing. Now a lot of you guys are probably going, where did that come from? Did you make that up? Okay, and actually it's been from what we've been practicing. It actually comes from this. If you notice, the letters are pretty much similar. Okay, and here's the really cool thing, is that if I complete the square on this formula without any numbers in for A, B, and C, voila, I have completed the square and I've gotten the quadratic formula. Now I'm not going to do that today because that doesn't benefit anyone, but I want to give you a very useful tool to actually use, okay? So before we start on working with it, I want to talk about the many methods of solving a quadratic. So the many methods are graphing and finding the zeros. In other words, where the parabola crosses the x-axis. Now, as you guys remember, we didn't have every single parabola across the x-axis. So sometimes you might have to solve by square rooting. But sometimes you might be square rooting a positive or a negative number, and that's not possible. So we came up with another one, factoring and using the zero product property to find the roots. Okay, and remember, zeros and roots are both the same thing. They're just two different words. I want you to know that they're getting the same thing. Okay, but sometimes you couldn't factor, and it was like, okay, now we came up with a method called completing the square. Completing the square works, yeah, that's great and everything, but what if we get, once again, the square root of a negative number? Okay, that's where this end-all be-all comes from. Okay, now you guys might have heard the term, but this is the skeleton key to solving quadratics. So if you go home today and you're like, oh man, I just want to solve quadratics using the quadratic formula, no one would ever fault you. Okay. Now, skeleton key is a key that would unlock all the keys in a jail or all the keys in a city. Usually a sheriff or a chief's constable had one. And if you ever hear about them, that's exactly what it means. This one, if you use it every time, it will work correctly every single time. It's unbelievable how well it works. And it's very, very helpful because everything is just set up as is. Now, sometimes you might be doing the square root of a negative number, and that's okay. You just say, we'll talk about that more in a second. We would say no real solutions. But when you get to that point, at least you've done everything you can to get to that point, okay? And that's a beautiful thing about the quadratic formula, is that later on in Algebra 2 you'll learn how to actually solve those and get those up to speed. Alright, so back to the discriminant and the quadratic formula. Okay, so the quadratic formula is everything here. The discriminant is actually just all of this stuff right here. It's the b squared minus 4a. So discriminant is b squared minus 4ac. Okay, now I have a tendency, a lot of people probably don't do this, but I have a tendency to put the 4ac in parentheses, and that there's a reason being is that if you get another negative number, you're not going to mistake this negative for it, and you will actually have the double negative that you need. Okay, now I'm going to put up some rules for working with the discriminant. Well, actually, yeah, I'll put up some rules first, and then we'll start talking about it. Okay, so now there's a law in math. It's called the law of trichotomy. In other words, either a number is equal to another number, or it's greater than, or it's less than. And there's only three options, and we're going to use 0 as our placeholder. Okay, so if the discriminant, which is b squared minus 4ac, is greater than 0, then we have two real solutions. We go on and we continue. Now, if the discriminant b squared minus 4ac is equal to 0, then we have one real solution. And if the discriminant b squared minus 4ac is less than 0, then we have two imaginary solutions and no real solutions. Okay? Alright, so let's try those out with some sample problems. Alright, so let's say we had to solve 4x squared minus 5x plus 7 equals 0. Okay, now if you notice, none of these, this is pretty much unfactorable and just unworkable. So what you're going to do first is you set a equal to 4, b equal to negative 5, and then c equal to 7. Okay, and then what you're going to do is plug it into the spots in the quadratic formula of where you need it. Now I'm going to take some time to put that in so this goes a little bit faster, but when I come back you'll see it all correctly plugged in. Alright, so after I get done plugging everything, this is what it's going to look like. Now if you notice, we're going to take this as a section at a time. So first section is going to be the first one, which is deal with this. So a negative, a double negative is definitely going to become positive. So this is going to become x equals 5. And then we're still going to have the plus or minus. And if you're wondering how to make a plus or minus on your paper, please use, here I'll write the code up here. It is Alt 241, had to think about that for a second, and then Alt 251 for square root. And the plus or minus is just representing two separate equations. So we're actually dealing with two separate equations at once. They're both similar except for that one spot where there's a plus or minus, okay? Alright, so now that we have that, we're going to deal with the bottom next, just because that is a lot easier. Okay, and 2 times 4 is definitely going to be 8, so that's nothing special, but it's just easier to work with. Now right here, I'm going to deal with the discriminant, but I'm going to go 25, because negative 5 squared is definitely going to be 25, minus, okay, and then this is going to be 4 times 4 times 16, or I'm sorry, 4 times 4, which is 16, times 7, which is going to be 112. Now I'm going to go, let me see, go 25 minus that, and I'm going to get the negative 87 under here. Okay, now if you notice, I'm square rooting a negative. Okay, now if I go back to my shortcuts, if the discriminant is less than 0, which it is, then we have no real solutions. So if they're asking for the real solutions, I would seriously say there's no real solutions and then move on. Now if they were asking for the solutions, I would say go ahead and give the imaginary number. Okay, and you'll learn about that in Algebra 2. So correctly, I should have probably put in the beginning, solve for real solutions of, there we go. Okay. All right, and that would definitely clarify a lot of things. So this is literally how I work on it. I first deal with the negative b, then I deal with the 2a, then I square the b, and then I times the 4a and then the c, and then I just multiply that, and then I subtract them, and then I look at my rules for discriminants, and I notice what the sign of this is going to be, and then I continue on if need be, or I don't. Okay, so let's go try another one. Alright, so once again, you define A, B, and C. Now, if you'd like to try other methods, you can, but since we're just practicing this one right now, we are just going to go ahead and start plugging in the numbers. Okay, so I'll be back in a sec with the actual plugged in version. Alright, so I'm left with this, and I'm definitely going to put the fraction bar between them just to separate it a little bit. Okay, so what I'm going to do is I'm just going to write the numbers above. So this should turn into 5. Okay, this should turn into 25 minus 24, which is good because that's going to give me a positive answer, which is what I want. Okay, and this should turn into a 4. Remember, 25 right here, negative 5 squared is 25, and 4 times 2 is 8, times 3 is 24. So this all turns into 5 plus or minus the square root of 1 over 4. Okay. Alright, so we have this all set up. Now if you notice, we can find the square root of 1, which is just 1. So this will actually turn into 5 plus or minus 1 over 4. Okay, so some of you guys are probably going, oh, that's great. Now I can actually get 2 solutions because that is the discriminant is positive. But how do you get those 2 solutions? Okay, so what you have to do is you have to go off in 2 separate paths. You have to go one positive and one negative. So in one of them, I'm going to have, seriously, 5 plus 1 divided by 4, and that's going to be 6/4, which turns into 3/2. Okay, pretty simple, pretty straightforward. All right, now the other one is going to be 5 minus 1, okay, divided by 4 equals 4 divided by 4, which is just 1. And voila, I have both answers of that. Now some of you guys are going, wait, could we have gone back there and factored this and got the same answer? Yes, you could have. You could have definitely done the AC method. And that might have been better, but you know, I just wanted to show you the quadratic formula. I wanted to show you if you were like going, I'm going to check my answer and see if it crosses the x-axis and where it does. And you would find that it crosses 1.5 and 1. Okay. Now, as for the rest of the problems, if you end up getting a square root that you can't simplify right here, like for example, let's say the square root of 79, but it's positive, just stop right here. So you don't need to go beyond this step, okay? But if you do find that you can square root the number, you do need to go off on the two paths of answers, okay? All right, so that's it for dealing with quadratic formulas and everything. And just remember, if they're asking you just to find the discriminant, just work with the b squared minus 4ac and then check your answers with it, okay? All right, that's it for dealing with the quadratic formula and discriminant. I'll talk to you later. Bye.